When we solve exponential equations, there's a couple different types. There's exponents on both sides and there's exponents on one side. And there's a couple different strategies. Honestly, once you learn a couple tricks, these are really easy equations to solve. So the first type is exponents on both sides when the bases match. So notice that this says 5 raised to the stuff equals 5 raised to the other stuff. What has to be true about the two sides of an equation? Are they like different, or what does the word equation mean? Equal. The two sides have to be exactly the same. So if the 5s are exactly the same, then what has to be true about the stuff in the exponents? They have to be the same. So 3x minus 2 has to equal 5x plus 8. Is that an equation that we know how to solve? No. Hopefully, from Algebra 1, you still remember how to solve a multiple step equation. So the key in number 1 is if the bases match, then the exponents have to match, put the exponents equal to each other, and solve. We would subtract 3x on both sides, or subtract 5x on both sides. And then we would subtract 8 on both sides to get negative 10 equals 2x. So what does x equal? Negative 5. That was super easy, right? Yeah. Exponents equal to each other and solve. Number 2, there is a typo. That minus 1 is supposed to be in the exponent. So notice on both sides we've got e raised to the something. Because the e's match, the somethings must also match. So 3x must be equal to 2x minus 1. Okay, now let's be honest. Do we really need to take the time during notes to solve that equation, or do you feel like you got it from that point? You've got it from that point? Okay, now what's the problem in number 3? Can we do the same thing in number 3? No. No. Why can't we do the same thing? Not the same number. They're not the same number. So I want you to think about 8. Is there a way that you could rewrite 8 as 2 raised to the something? 2 squared is 4, 2 to the third, 8. So if 8 is the same as 2 to the third, I can take this 8 out and put 2 to the third in its place. The original exponent x would just be multiplied to whatever new exponent you have. And I put it in parentheses like this because if this had said like 8 to the x plus 4, you would need to multiply that 3 to the x, and you'd have to multiply the 3 to the 4. So whatever exponent was originally there, put that exponent in parentheses after the new exponent. So 8 left the equation, 2 to the third went in its place. The original exponent just goes in parentheses after. Now we have 2 to the stuff equals 2 to the stuff. So first stuff, 3 times x, has to equal other stuff, 5x plus 2. Could you then finish solving that? Okay, let's try number 4. 27 and 3 don't match. So we need to think about, can we take 27 and rewrite it as 3 to the something? 3 to the third. So 27 is going to leave, and 3 to the third will take its place. The original exponent 2x just goes in parentheses after that 3. Now, 3 to the stuff equals 3 to the other stuff. So first stuff, 3 times 2x, or you could just go ahead and write that as 6x equals 5, and you could finish solving it. If there was more in those parentheses, you would have to distribute. If it ended up being like a 2x plus 1, you'd have to do 3 times the 2x, 3 times the 1, and so on. Okay, so there are two types of exponents on both sides. One is when the bases are the same, and one is when the bases can be written as the same. You just have to do a little bit of trickery to rewrite the bigger one in terms of the smaller one. At the bottom of the page, there's two specific types of problems. There's exponents on both sides over here on the right for number 4 and number 8, and there's exponents on only one side. We're going to do 5 and 7 first. Exponents on one side. Notice the notes at the top of this section. Make sure you isolate the exponent first. So if there was something added after the 2 to the x, you'd need to subtract that. If there was something multiplied in front, you would need to divide that. This one is already done. So 2 to the x equals 7. X is stuck in the exponent. Anytime you are stuck, I want you to write this down. When stuck, change forms. Do you remember the log ride from the first day of logs? Okay. We'll see if I have the energy to do the woo today. Do you all have energy to do the woo? No? I'm so sorry, people on the video. I don't think they're going to be very enthusiastic about the woo.
It's the one day added. It's one day.
Okay. So we are stuck. We need to do the log ride. We need to change forms. So woo! We are changing this from exponents to logs. So we have to write down log. The first number that we write down is the 2. That's the base. The next number is the 7. That goes inside the log. And then the next number is equals x. So you follow the log ride around, and that shows you the order that you write the numbers. Okay. Last week, we learned how to do log base 2 of 7. You can do this in a scientific calculator using change of base, or you can use the fancy graphing calculator feature. If you do this in a scientific calculator, you would do log button 7, close your parentheses, divided by log button 2, close your parentheses. And you get x equals 2.8, 2.807, depending on how it asked you to round. Do you remember the fancy keystroke to get the log base thing in the calculator? Alpha window, 5. Then you can type in log base 2 of 7 and still get 2.807. Number 7. Is the exponent isolated? No. We need to get rid of the 4. How do we get rid of the 4? Divide by 4. E raised to the 3x equals 3. We are now stuck. X is in the exponent, and we're stuck. So we change forms. Woo! Log base E of 3 equals 3x. Anybody remember anything fancy about log base E?
No.
That's a flat no right there. Wow, my confidence as a teacher is spiraling the drain right now. Do you remember the other button on our calculator that is similar to the log but isn't exactly the same? ln. Log base E is ln. So we can punch in ln of 3. What do we need to do now to finish solving to get x by itself? Divide by 3. You can leave this big long decimal in your calculator and type in divided by 3. That will get you a more precise answer. Our answer should be x equals 0.366. If you decide to retype 1.099 and then divided by 3, you will get something similar, but your rounding might be a little bit different. So in your answer keys, if the rounding, if your answer is a little bit different from mine, it might be because you rounded in a different spot.